Now, we are here on location in Tampa, Florida, actually in Clearwater, a few miles west of Tampa. The American Academy of Discipline and Sciences would have the pleasure to present another interesting documentary on the properties of falling bodies and on the free energy designs of a dozen of scientists that were investigated in great detail by Mr. Don Kelly. We met at the Global Science Conference in Daytona Beach, and I came all the way to his home here in Clearwater to see all the experiments by myself. So here is Mr. Kelly himself.
Okay, thank you, Vladimir. I guess the best way to start this is to just state flat out that we do have successful free energy machines today. Not only are they successful, but they're in three categories. We have dynamic type machines, which are represented here by the N machine, and then we have the solid state. Solid state machines.
No moving parts.
No moving parts, right. And then in between we have what we call a hybrid, which is a combination of both the dynamic and solid state. And the best embodiment of this hybrid system is the Swiss converter. Now, I'll be going into detail on these as we pass by, but I just want to lay out the ground rules for these three specific types of successful free energy machines. Now, the N machines are essentially divided into two types. We have the EM type, which has windings in the rotor, so it's essentially an electromagnetic N machine, and the windings produce a magnetic field, which is necessary and is the basis for their operation. Then we have the fully magnetic type, which uses permanent magnets in them. So these both work quite well, and these are non-inductive machines, and they are not like our regular motors and generators that utilize Faraday's induction. These do not have external coils. See, they produce a magnetic field by direct interaction with space energy, so they are non-inductive. Now, I'll start going into detail on the N machine now, and show...
on the mechanical N machine.
Okay, yes. And there again, you see I've got these two columns, one showing the EM type, which has the windings, which produces a magnetic field. Now, that magnetic field interacts with space energy and produces an output. Now, the positive output is at the periphery of the drum, and the negative is at the shaft, as we show here. In this specific case, the positive brush contacts the outer face. Now, usually that's done at the periphery, but it can be either way. Now, one of the requirements for the EM type is that you have additional brushes to bring the EMF or current into to energize the field windings. So that the EM type of N machine tends to get a bit more complicated because of this requirement for the extra brushes. Now going over, and then here are some charts that tie in with the characteristics of this EM type machine. I won't go into detail on that. But now we'll go over to the fully magnetic N type of rotor. Now this is built with both ferrite magnets in the core and neodymium magnets on the faces. Now, the neodymium type of magnet is the latest evolution in permanent magnets, and they are very powerful. Now, in this specific rotor, I have 24 neodymium magnets on either side. Of course, one face is North Pole, and the opposite face is South Pole. But in this specific pattern. Now, this is just to illustrate that you can have an increasing number of magnets. This particular one has 40, but there's essentially no limit to the pattern. There's no specific requirement for any type of geometric pattern in these. It's just you try to cluster them in the most effective manner. as it's done here.
Sandwich, south, north.
Yes. Well, no, this is purely just one face. See, it's just a single layer.
Yeah.
So one face is north and the opposite south. That is a requirement. Now, a very interesting thing about this magnetic flux. Now, you'll notice because of the use of these very powerful neodymium magnets, we get a very enlarged flux pattern. Each pattern is actually longer than the rotor itself, and it bows out somewhat. And also, you have the peripheral flux pattern.
Probably.
Oh yes, that's one way to do it. Or you can use a little magnetic detector. This is essentially to scale. What you see here is pretty much to scale. So this is the pattern that you get. But the most remarkable thing about these magnetic flux patterns is they remain absolutely stationary as that rotor revolves, which was an amazing thing to me because I just naturally assumed that the magnetic flux is revolving with the rotor, but it's not so. It doesn't. And the only thing is, now, I haven't explored this fully, there may be a boundary layer that does drag revolve with the rotor, but the essential pattern, the bulk of the pattern does not revolve. It's absolutely stationary, which was amazing to me. But in any case, there is an interaction with space energy that causes an EMF, positive at the rotor periphery or end plate and negative at the shaft. So that is, pretty much covers the end machine, except to say that they are the characteristic for them is a very high amperage output at very low voltage. So they are somewhat the reverse of the electrostatic type machines. These are high amperage machines at low voltage.
Yeah.
Which is part of the problem, because then you're kind of limited to the applications.
This is basically the De Palma.
Yes, there are quite a few people that have been involved with the end machine. Bruce De Palma is considered to be the pioneer, the founder of the field, but there are other people. Most notably is a doctor in India, Dr. Tiwari, who has done, he's kind of expanded the work from De Palma. And there are several other people that have gotten involved with it. One of them that comes to mind is Adam Trombley. Adam Trombley worked on this field and developed his own design, which was patented. And that specific patent was held secret by the Department of Defense. So you can see that there is significance to this type of machine. I think that pretty well covers it. Only just, there's one point I do want to make. We shouldn't look at the end machine or any of these machines as they are. We should be looking at them as to what they can become, because we are making progress with them. One of the problems is picking off the very high amperage. Now, the latest development in the field is by an Austrian inventor who is now using a 3 microwave field to pick up the very high amperage.
A very brief little note here. A friend of mine was digging in the libraries and he discovered in an obscure economics newspaper, which I would produce at the end of the film, I'm mentioning that the Navy built a 3,000 horsepower end machine ship, and there's a photograph of the ship rolling in the bay. And also, the same friend found in the library a contract by the Navy to find subcontractors to build ship propulsion units between 20 and 50,000 horsepower based. It's very carefully worded, but if you read it between the lines, machinery with spinning magnetic field, which is the code word for a homopolo generator, with brushes of liquid lithium, being quite a dangerous element. They require a lot of hermetization and so on. But it's obvious that we are talking about thousands and possibly millions of amperes running through these brushes. So these are very powerful propulsion units.
Okay.
Yeah.
Time is okay. Okay, we're going to the next one. Now, this is the, as I mentioned before, as we started out, this is the hybrid type of machine. Now, the most prominent, the most well-known of all the hybrid machines is the Swiss ML converter. And that is produced by a group in Switzerland, which is essentially a religious commune by the name of Menertha. Menertha, that's the correct name. I always have a problem with that name. But anyway, it's a remarkable machine in that it's a double, as I mentioned, a hybrid. It uses a dynamic portion which consists of the electrostatic disc, generally similar to the Wimshurst electrostatic generator. And that produces a high voltage, contrary to what we saw in the N machine. Now we're talking about high voltage and low amperage, which is the converse of the N machine. But that this type of disc here produces somewhere up around 75 kV at about 0.02 microamperes. So that breaks down to roughly about 150 watts. So you see that's a relatively small output power-wise from these discs. But what happens in this remarkable machine is that relatively low wattage gets amplified in these two elements here. And these components are essentially bifilar wound coils, which are non-inductive coils, and we're starting to see this component come up time and time again.
Coils are basically, how should we define them?
Yes, very, very easily. We say that it's just a coil that you start down in one hand direction over some sort of core. The core is immaterial. You just wind it down, and then you wind it down back down over itself. In the opposite direction. So
basically you're winding the coil with a double wire, and this double wire is soldered and connected. The two strands are connected to each other at the end.
Yes, yes. So that's a key element that we're starting to see occur in several of these devices. So this becomes a critical component. And but in this case, we do know that these bifilar windings are wound over barium ferrite magnets. They use radio-type ferrite magnets here. So this is a very important component. And this is where the conversion occurs, and that conversion comes out to be between 3 and 4 kilowatts. In other words, that's between 3 and 4,000 watts.
So what is the input and what is the output?
There is no input because...
There's no input.
None. It's a cell. This is one of the true free energy.
The input in the converter in these bipolar.
Oh yeah. Oh yes. That would be the 100, roughly 150 watts. You see, going in.
150 watts in the bifilar coil.
Right.
You get as an output 3 kilowatts.
Between 3 and 4 kilowatts.
So it's about 20 times.
Oh, at least that.
Yeah.
But then technically, you have to say this is a true over-unity machine in that. There's no input, because now that brings me to these small components here. Similar, these are just, there again, the same non-inductive windings over horseshoe magnets. So here you have a small version of what we have over here. Now the function of these is to actually power the drive. This is actually a feedback circuit. So we're taking that power and feeding it back to run the motor to run these discs.
I see.
So
it's like the charger, like the activator coil.
Well, yes, it's essentially a feedback circuit. So it makes this whole system self-propelling. In other words, there is no, technically there's no input after. I'm omitting a very critical item. These discs are actually started by hand. Now, that's just an optional thing. They could be started in the beginning.
Do you have to turn them?
No. After the initial input, just to get them going, and I have pictures of the people doing that. Once they get them revolving, then they will keep going. And it's quite easy to do because the discs revolve at only 60 RPM. It's a relatively, it's a low-speed machine,
as I said. When the machine starts, then you don't have to turn the disc anymore.
Then they are self-running, self-propelling after that.
Is there an electrostatic motor to run these discs?
No. It's just an ordinary DC, small DC motor powered by this feedback circuit.
I see.
See, so essentially, you have to say that this is a true free energy machine. So now here are some examples. This was one that I built. It was not successful because we did not know all the information on it. Now this is an example of a commercially available Wimshurst electrostatic generator, similar to what they're using here. Now there is a difference. These discs, these segments, I should say, are aluminum, but in the Swiss ML they are stainless steel. So there is a difference. So I think that pretty well covers that. All right. Any? Yes. Okay. All right. Then.
Cover the sheet with that little piece of wood in the back.
Oh yeah. Right. Okay. Yeah. So we won't get it all blown around. So. Now we're talking about solid-state systems now. Now, the most prominent of all the solid-state systems that we are aware of is the work of Dr. T. Henry Moray. Now, he started back in the 20s, and the Moray system can be very generally likened to a radio type of unit because he did use multiple vacuum tubes in it. And here is a picture of him with the unit. As you can see, it's not a very big unit, about the size of a roughly a small microwave oven. And he's lighting this. This was just a temporary load that he was using. Most inventors do use multiple light bulbs as a load. Now, back in 1925, now this is this may or may not be the unit he used at that time. A unit produced 30 kilowatts, so we're talking about quite a sizable amount of power from this one. Now, unfortunately, nobody, and even Dr. Moray's son John, has not been able to duplicate this. Dr. Moray did not keep. He kept rough notes, but he didn't keep them in the regular notebook fashion. So a lot of the information is just lost to us. So nobody has been able to duplicate this one. Okay, now we'll go on to a Russian. This is known as a plasma generator. There's not much information available on this. There are only a few people in this country that do know more about this. Dr. Hal Putoff is one down in Texas. And this one is said to, there again, it's a solid-state type. It's said to produce 2,000 watts with a 700-watt input. So, we're roughly talking about a 4-to-1 or 400% efficiency on this. But I can't go into this too much because we're just missing the information on it. Okay, now, this is another very interesting solid-state system, and it's a late one because it was started by Floyd Sweet. And this was started somewhere around roughly around the mid-'80s. So it's the later, or I should say the latest of all the solid-state units around. Now, here again, the interesting point about the VTA unit, now that stands for Vacuum Triode Amplifier. It's, you actually could call it anything, but it does generally seem to mimic the action of a triode tube in its general nature. Now, the input to this one is quite low. They use a 10 volts at about 1 microampere, so we're talking about 10 milliwatts, very tiny current. Now, this was done several ways. In one case, he used just an ordinary 9-volt battery, but it had to be fed into a 60 hertz oscillator, because this is essentially the input for the Sweet unit is 60 hertz. So we're talking about.
It resembles a transformer core with some core with.
Yes.
Wound on it.
Yes, it's.
And
again a bifilar, very much so. This would be a general picture, and you can always tell a bifilar because the ends of the coil always come out of the same end. You see, because if you're starting one end and then coming back over itself, the two ends are going to come out of the same end. You see, so that's very typical of a bifilar construction. Now, we believe these are negative and positive. That's twin. Now, this picture is a little bit out of context because it doesn't represent the true VTA unit. and it was used in my gravity drop test, which we'll get to later on. One of the features of this device is the magnetic cores use special, what he calls conditioned permanent magnets. Now, we don't really understand what that consists of, other than they are said to be magnets that are broken away. The magnetic domains are broken away, so they don't represent a true north-south polarity. You have tiny increments in there that are polarized, so we're not quite sure of that. And there is a brief description of what we thought was the description of these conditioned magnets, but it is a proprietary. You have to keep in mind this is a this is a it's a power.
If you can keep the mic closer.
Yeah, right. No, this chart actually shows a weight loss. Yeah, this was Tom Bearden found that there is a weight loss, and I've confirmed that when this VTA unit operates, it goes through a considerable weight loss. So now we're starting to. Yes, yes. In his paper, Tom Bearden claimed when it was operating normally, there was a 90% weight loss. 90, which is incredible. Now, during my testing, I didn't find that high. This experiment, and that was through the gravity drop. Now, we'll be getting into that later. This specific one showed a 40%. But nevertheless, whether the percentage varies one way or the other, it's making his point. He's showing a definite weight loss for an operating unit like this. So I think this one covers it, but there again, you see, this is a proprietary unit, so there are elements in it that we don't fully know. One other very important point to this is cannot be considered a fully ready-to-go unit, because what happens with it, which nobody yet understands, it'll operate for maybe 10 or 15, we don't know what time period it is, but suddenly it'll just quit. Just quit. And nobody really understands yet why it does quit. So you can't leave this one without making that comment about it. In other words, we have to look at this as R&D in progress. It's an R&D type unit. Very interesting, though. And the key thing about it is it's showing up this very valuable component of the non-inductive coils over permanent magnets. Okay, now we're getting into an area of more or less conventional Faraday's induction. This is a gentleman, Robert Adams, in New Zealand, who has been at this work for quite a time now, and he has evolved a combined motor-generator arrangement. Now, he uses motorizing coils here, reacting with permanent magnets. We're getting some rain now, huh? And you have the motorizing coils and the generating coils. Yeah, I do have, no, we're past that. No, we're okay now, I think. Yeah, right, okay. But this one, now, Adams claims a 270% efficiency. In other words, that's, it's a considerable increase of the output over input.
Mechanical device.
Essentially mechanical, yes.
Sure.
So it would be in a...
Four permanent magnets in the rotor?
Yes, that's correct.
Two driver coils in the starter?
Yes.
How about the other four coils?
These are generating coils. Yeah, so...
Basically a motor that generates
yes.
electricity plus producing some axis.
Yes, plus a torque, too, which is used. Now, here he's showing a rough form of Fermi brake here to measure the torque output. So here is it's kind of a pictorial view of it.
An aesthetic test.
Yes, yes. Okay, I don't think we should spend too much time on these. But this is also, now, keep in mind, this past one we just saw here, and these are all essentially Faraday's induction. In other words, they're conventional. We must consider these conventional machines with variations. Now, this one is unique in that the inner rotor revolves contra to the outer rotor. In other words, these are counter-rotating, right. And this is done through the use of, he happens to use a planetary gearing arrangement in that. Now, here's a tandem version of this unit here. There's no real data. Mr. Schottelmeyer has not provided us with any operating data, so we can't pass any judgment on this. You know, it's a kind of a unique system because this is the first time that these contra-rotating electromagnetic components have shown up. So this seems to be kind of unique. Schottelmeyer, right.
Germany?
No, from Netherlands. Netherlands, right. Okay, and then we go to Barbara Hickox. Now, there again, keep in mind that this is still Faraday's induction, because there you see the magnets and there you see the coils. So you've got a magnetic field reacting against coils. Whenever you see that, you know that's Faraday's induction. The unique point about this one... No, this is a regular, ordinary, conventional type principle involved in both of these plus atoms. These are conventional type units, except for the fact that now here's the chance for equal opportunity. Women get involved with these things too. But the unique thing in Barbara's devices is she's using permanent magnets. Oh, yeah, she's using permanent magnets in a helical pattern, which is never in the rotor. This has never shown up before. This seems to be a unique device for her. Now, I understand. No, she's kind of self-taught in this. But she's been at this a long time, I understand, from what she was telling me. These are ordinary ferrite magnets, mind you, so that kind of puzzles us. We thought she might be going to neodymiums there, but they are ferrites. And the theory behind this, as she explained it, is that it tends to set up a traveling wave. Now, we don't quite understand that, but all we can pass judgment on is the fact that this helical pattern is unique. So, there again, no...
The phenomena in nature go in a helical pattern, so probably she uses this natural state of...
Yeah, but here again, like Mr. Schottelmeyer, no firm data. In other words, we don't have any hard numbers to judge it by. So you have to say that the jury is still out on these type units. Okay, now this is a very interesting device. Now here again, we're in the dynamic type of system. Now this is an electrostatic. Now this is a variation by William Hyde, and this is a sheet from his patent drawing. The unique thing about this one is that he revolves both discs in the same direction. In other words, he's just got a common motor in the center driving both discs in the same direction. Now, this is very unique, unusual in electrostatic machines, specifically the Wimshurst type machine, where they revolve in opposite directions. But now, since he's elected to make a system like this, he has to excite the electrostatic plates with an electrostatic field that happens to be 3 kV, positive, negative, and that's how he establishes the electrostatic field. Now, the interesting thing about the Hyde machine is that he uses a solid-state circuitry to divide the voltage. In other words, he steps down his very high voltage. He claims his voltage is up around 200 kV, very high. That's unusually high. You only usually get that kind of voltage in a Van de Graaff type electrostatic generator.
Kv can be easily used for electrostatic anti-gravity propulsion.
That is possible, yes. And here's his data here. He is claiming there, yes, here's the 300 kV that works down to 20 kV at the output. We don't quite understand yet how he gets his amplification in this, because this is essentially a voltage dividing circuit here. So we're not sure how that amplification takes place. But apparently it does take place. He's claiming it anyway. And anything in a patent is usually has to be respected in most cases. Otherwise, if it's not, then the patent has no value. So that, I really can't spend any more time on that, except to say that people have tried to, we've had several people try to replicate this, and none of them have been successful. So there again, this is this one has to be considered R&D in progress.
Yeah.
So I guess we won't cover any more time on that. This is a wind system. Now, this is another solid-state type of system. This shows his, this is Dr. Wingate Lambertson of Holmes Beach, Florida. And this is his electrical lighting system that he's worked out. Now, later on, I can show you the schematic. This is more of his specific lighting application for his wind system. And it is, he is claiming ZPE to lighting. So, and he's got some charts on this, and he has other people now working for him on this project. So I won't cover any more on that. And then now we have Stefan Marinoff of Austria, who is very well known in Europe for work. Yes, and he has. This is almost self-descriptive. I really don't have to say too much about this. This is his terminology for this. Is an electromagnetic generator, which he calls this Vidin Kalyu. I'm not sure how to pronounce that, but there again, this is kind of work in progress, and it is in the R&D stage.
Tell us about the generator, how it is made.
I'm sorry, I can't help you on that. I'm a little bit fuzzy on it. I don't fully understand Marinoff's work. But other than to say that it is based on Faraday's induction, it is. So it does. It's not. As we understand this, it's not true space energy as in the N machine. See, this cannot be classed in the N machine class.
Yeah.
See, it's more or less conventional electromagnetic induction. So I really can't say too much about this. It's light enough now. Now, this is the background on Hans Kohler. Now, we say he's a pioneer because he is the first one on record to identify this specific type of bifilar winding, or non-inductive winding. And so he must get credit for all these later systems that are coming along. Now, apparently the people that worked on the Swiss ML converter were well aware of Hans Kohler's work. And there again, he specifically wound, and this device right here, this is his magnetostorm apparatus. And he does show these types of winding over permanent magnets. Now, not only does he identify bifilar windings, but he is specifically identifying them wound over either Alnico. I think they must have been Alnico magnets because he worked in the 1930-1945 time period. So they were probably Alnico magnets. And this was a duplication of the one of Kohler's.
Information on the power that was squeezed from these devices?
No, it is in record. Now, these documents that you see here were taken after the war. British intelligence retrieved this information, and a lot of that is in the record. And they do have numbers. They have numbers on the output. It wasn't very, wasn't high, but it was over unity from what we know about it. Okay, I guess we can move on then. Yeah. Victor Schauberg, he was a giant in the early days of the environmental movement. He might even be considered by some to be the original environmental man, because his belief was that we're going, our applied science is all wrong in that we use explosive machines. We use internal combustion engines that explode the charge, the air fuel charge. Yes, yes. His belief was that we should be imploding. We should be using the form that nature uses to break down elements into energy. And specifically, he had this. It's called a hyperbolic spiral, and this was an application of it right here. And it was an imploding.
Be cleaning impurities from lakes and water.
Yes, he was into this. He was into
Go a step further, saying that it would move matter into energy and basically evaporate and thin the...
Yes, that is possible. But of course, he met with, as all do pioneers meet with, quite a bit of resistance from the powers that be. So he was never able to prevail in getting his ideas across. So some of them did. He was helping farmers to build far more efficient plows to turn the soil. So using his techniques. So he's quite a pioneer in the whole field of ecology, long before his time, really. Now, he was active in the 30s and 40s. He was actually, he came to Hitler's attention, and he did get involved in UFO work, but I think...
So his devices were basically spinning fluid, spinning water.
Yes, yes. Right, no, nothing like that. He was, really, his expertise was in hydrology.
Yeah.
So, and there again, the work is all lost, just bypassed, and you start to wonder why it's so. You know? Okay, now this is a very interesting picture. This is a full-scale duplication of a magnet stack that I have, and these are ordinary barium ferrite magnets. The interesting point about this is when you put a core or a hole in a disc. These are all identical increments of disc formed into a stack. Now, what happens here is a very interesting feature. When this happens, you're setting up local, on the end, you're setting up north-south flux patterns. So the flux loops go across here in addition to doing this. Now, we're not sure which comes first, but it may be that these flux loops here are causing some sort of internal tension. And also, the thing here is this is a fairly long stack, so normally the magnetic flux goes from north to south, as is shown here, you see. But in this type of geometry, when you have a hole in it, now this is an ordinary solid bar magnet, and you get a normal flux pattern from south to north in that direction. But when you do this to it, when you change the geometry, you also change you're causing these localized flux loops. Now, another interesting thing here is, over time, these lengths change. Now, I'm showing these to be about 3 inches. I have the same stack now, and the pattern has changed. One is 4, 3, and then 3.5. In other words, there is some sort of internal tension that happens that cause the variation in the loops. But nevertheless, now here is one where that shows it clearly here. The little white dots are showing just what you see here, this looping.
The purpose of this making of holes for the production of free energy?
No. This is just part of the manufacturing process, as far as we know. We don't believe that has any significance.
Of what?
Well, to facilitate the forming of these. Now, these are sintered magnets. I cannot address that. I really don't understand, but other than to note what I find here.
But why is this important for this whole presentation?
We don't know yet. In other words, now we're strictly into R&D. We see this is happening, and of course this is exactly what they're using in the Swiss converter. And what I'm asking is, I'm just really asking the question, is this significant to why the Swiss converter works as well as it does, you see? So I can't, I'm just making an observation to what I see. And this is very, very unusual to see this end. Now, if this were solid, you wouldn't see that happen.
Yeah.
See, that's the point I want to make. If this were solid, there'd be no local transfer like that. So it's more or less an observation of something that we don't quite understand. So, okay, I think we'll move on here. And well, this is a very vivid picture of a normal. Now here again, this is a bar magnet, not hollow like this. This is solid, and this is the pattern that you get. Oh, yeah. Yeah, this is a Well, here you have it in schematic form, but this is actually a photograph of the flux patterns here.
Yeah.
Now, the interesting thing, in a normal, there again, it's a solid bar magnet. The South Pole pattern is distinctly different than the North Pole pattern. They are different. And the flow is different. The flow is from south to north
Yeah.
in an irregular loop like this. So,
This
okay.
is a bar magnet with a hole in it.
Yes, there's the difference. See, here you see what happens with a solid bar magnet, and here you see quite a difference, quite a distinct difference in the separation or breaking up of the flux patterns when there is a hole present. So it's rather significant, but it needs further work. That's the only comment I can make about that. I class these as components that are significant to some of our current work. Now, the N machine, the EM type of N machine, can possibly benefit by the use of special windings. Now, ordinarily, the N machine is just made with copper wire, off-the-shelf copper wire. But now it is possible to increase the magnetic field by using tinned copper. In other words, that's ordinary bus wire, and the only reason it's tinned is to facilitate soldering. But what I found, and I did some testing on this, and I found that the tinned copper or bus wire does produce a higher magnetic flux. And it's about, let's see what I can...
Stolberger was using copper sheets for his sources. So this
Yes. Yeah, there may be a connection there. But the upshot of this is that if you use tin copper, you get almost a tripling of your Oersted's flux, or magnetic flux, around the wire. Now, you can go higher if you use iron wire. You can go up to 4, but unfortunately, your resistance goes way up. So that's not a good choice.
Yeah.
You don't want your resistance to go up because you're going to get heating, which you don't want. So the best choice in this would be tin copper bus wire. Now, this is sort of an experimental component here. This is a way of achieving DC voltage dividing. In other words, we don't have a comparable component in DC that we have to an AC transformer. This may be a way to get a voltage reduction for DC machines. Now, I was led into this. Yes, no. This is solid state. It's just an ordinary electrical device. Quite simply, all you're doing is going in with your high voltage, and you're splitting it up by whatever number of lines you have here. If they're 20, you're dividing the voltage roughly. Now, there again, you're not going to get a uniform division, certainly. You'll get a rough division. If you're within 10% on each line, you probably, that's about all the accuracy you can expect. But nevertheless, you are dropping your line voltage down very, very sharply. Voltage splitter, right. And this would be specifically for the electrostatic type machines that are putting out a very high voltage. So this may be, I haven't gotten into this. It's just in the conceptual stage right now. But it could be very useful for electrostatic machines. Okay, we'll move along. These are some other free energy devices. There's a significant one by a fellow named Ken Shoulders from Texas. And it's a very profound patent. This patent happens to be 80 pages, so it's one of the...
What is a mechanical or
No, it's solid state. Yes, it's a solid state system, and it's based on... it's a plasma type using high charge density, and I'm really not too much up on this one, so I can't make two comments on it. Okay, yeah, now this was going back to wind system, which we covered for his lighting application. This is his basic circuitry, and the key component in the wind system is his Cermet material, which are actually, what it boils down to is, this is a photon trap. So he's collecting photons in very high numbers in a very high porosity material in this component. And the rest of it, you see a tank circuit here, and here's the light bulbs that he uses as his load. So there again, he's collecting high numbers of photons in this, and there's an amplification that occurs in here. This is another one, Spence. This is he calls this an energy conversion system. This is essentially a spiraling of electron field, and he's getting some sort of a step up. Experimental. It hasn't been built, so you always have to make that distinction between a prototype device and one that is just theoretical. Moore King's analysis of Hyde circuitry, which he does endorse. He believes that this circuitry is correct. And then we have the Reed motor. Now the Reed motor is essentially, now we're talking about a dynamic magnetic machine, which converts pure the energy of within magnets within the machine. Now, one of the big problems with all sorts of magnetic motors has been the idea that the passing magnets will always attract, so therefore it's very difficult to extract any motion from them because you're getting the attraction. He's overcome that with these spring plunges, which provides just an instantaneous amount of torque to the shaft to get the magnets to pass one another so they can gain from the repulsion. So that's the upshot of what his system is. Very clever device, very clever design. Yes, it is. Yes, he's coming very close now to getting an operational unit going, actually a production version of it. Very close to that. Okay, we'll keep moving.
How much more do you have to go?
Not too much. Yeah. Now, okay, we're getting into the gravitics now. These are people that had done pioneering work in anti-gravity, and we're coming to understand now that there is a connection between free energy and weight loss in these systems. So there is an anti-gravity aspect to free energy. They are connected. William Hooper has done significant work, and here again we see this component showing up again, the non-inductive windings. And this is specifically the Hooper coil, which is his own version of a non-inductive winding, in that it's wound on a flat plate. Now, all the other types are wound on a coil form. His actually is just all it is just back and forth loops, so that each doubling back loop cancels the magnetic flux of the preceding line. So, and then of course he keeps going that way. This is significant as in the gravity sense, in determining.
Moving parts there?
None. No, it's all solid state. Yeah, it's all just the coil, right? And what this does now, when you cancel your magnetic flux, all you've got left is an electrical field. So these are electrogravitic devices, both Hooper and Brown. Now, Brown was quite different than Hooper. Now, Hooper used the coils as an anti-gravity component, whereas T.T. Brown used two flat plates, essentially capacitors. And he found that there was a definite weight loss. Of course, he did use very high voltage. These had threshold voltage around 25 kV. So these were high voltage devices. And he found a weight loss. I'm not sure of the polarity. I think negative was up, positive down. But anyway, they lost weight when you passed that voltage through them. But distinctly different. In other words, they're getting to the same end results by different means. Okay. Now we're getting slowly into the other world. Yeah, now we're getting into my own specialty, which is trying to get a connection between the various field forces and gravity. This shows the stand. Well, that's actually immaterial. That shows the circuitry I used. And here we have one of the plates. This was an electromagnetic plate. So this is some of the mechanism, and I've got some postulates that I've posed for this. But now I want to get into the actual...
So these would be plates made of permanent or electric magnets?
That's correct, yes. Now, this was the first series of tests I did. This is the first drop test I did. Now, this consisted of 49 neodymiums in a 7x7 pattern in a flat plate. It was quite large. The plate was 20 by 22, so and fairly thin. But then, of course, I had to have a corresponding inert plate of the exact same weight, shape, and surface texture, so that I would cancel out all the variables and wind up with only measuring one variable, which is the time differential, which I did with this manner. Now, the time of dropping, but not in real time. Now, this was done in digital time, so right, artificial, just arbitrary counting, but with respect to one another. You see. So what you're getting there, and that's all you're looking for, is a percentage relationship between the dropping of the inert and magnetic plate. So, yeah, now what I found for this plate was a 14% differential. In other words, the magnetic plate fell 14% slower than a corresponding inert plate. And these are the...
with a permanent magnet.
Permanent magnets. Right, so, and there again, this is sort of the mechanism. Now, just to give a brief rundown on how this was done mechanically was that, or I should say electromechanically, is I just used two switches, one actuation and one stop, top and bottom. Now, as the test plate fell just almost instantaneously, it tripped the arm of the microswitch, which was then held. The arm, naturally, it had to be held in a closed position, so the circuit was actuated during the fall time. And then as soon as the test plate hit the microswitch, it would shut the circuit, and I would get the counter reader. I just used an ordinary 3-digital counter here, driven by a little DC motor, so it was simplicity itself. Now, I had been told it would have been better to use photocells, rather. When you do that, if you start to introduce photocells, you're obligated to have latching relays. So now you're starting to get a little bit more complicated. This was essentially the simplest way to do the whole thing. And, so I just stuck with my own method. Now, this is interesting. Now, this is the second magnetic plate, drop plate test. Quite a bit different in that instead of the magnets in the plates being normal, or would you say horizontal, these were on end. In other words, they were lateral, just up on end. And in addition to that, they were bucking. In other words, the two repelling forces were fighting each other. So what happens physically, now I measured that with a little detector, is that the flux loops get bowed out. They have nowhere else to go. In other words, you're squeezing on repelling magnets, so the flux loop becomes enlarged. So in this case, with this size magnet, the flux amplitude for this plate was 1.5 times. Now, normally, here you see at the ends would be the normal, uncluttered, unbucking magnetic flux. No amplitude. In other words, that magnetic flux from a flat magnet like this just goes right out from the face. It's not impeded by anything. But when you buck them, then the magnetic flux pattern bows out. Now, the upshot of this is you get, the other one was 14%. You do it this way, you get a 31% differential. And it's logical that you would expect that. And now I did improve the test procedure in that the first one was only 7, and I was severely criticized by that by peer review. But all right, I just took that. But now I increased the number of drops to 20. You see, that gives you a pretty decent pattern because you pick up a trend, and 20 drops is pretty decent. So, okay, there's the 31. Now, this is work in progress. Here we're getting to the Hooper coils. This would be an all-electric drop plate test. So we're getting away from electromagnetic and we're getting away from pure magnetic into all-electric. And of course,
coil would eliminate the magnetic component.
Exactly. Exactly. Because well, no, not bifilar in this case. This would be specifically, you'd call this Hooper coil. You see, because it's flat. It's not bifilar in the sense that it's wound around a core. you know, it's
but
round
still,
flat.
Still, the neighboring trends are.
Yeah, yeah, exactly so.
And they go consecutively in opposite directions.
Exactly. So that you see you're producing an Ørsted's flux when current is flowing here, but then when you back it on itself, the two flux patterns cancel, and they're successively canceling as you go. In other words, back and forth EMF in this way will cancel magnetic flux. So this is going to be interesting to see, and it's just work in progress. I got one more to go here. Here again, I'm just in the middle of this one. Well, actually, this is in two sections, too. This is work to be done. This one is the EM test. It's the first EM test. This will be the second EM test. But from this first one, I already covered that a bit when we were talking about the VTA. Well, this is almost a...
What is the VTA?
Well, that's a vacuum triode amplifier, Floyd Sweet. Yeah. So this is a... it's not exact, but it's a close simulation of what he did in that he used, or this one actually employed, the bifilar windings over the ferrite magnets, both cases, both, see, one negative, one positive. The interesting thing here is now we're looking at a 40% differential. So it's starting to climb now. Of course, it's apples and oranges.
Under power and without
yeah,
power,
right, exactly.
Is 40%.
Yeah, exactly so. In other words, here I have the column unenergized.
The mic points to that.
Yes, okay. In this column, you have, this is unenergized, 20 drops, energized 20 drops. You come out with, now these are just random digital numbers, 0.84, but percentage-wise, you're looking at a 40% difference. In other words, when it's energized, the EM field is reacting against gravity, quite clearly so. I mean, you can't refute the numbers. You know, even if there were some of the numbers in here are random. Now you see a 121 in here. That's a real oddball. You know, that was an odd number, but the pattern, the trend is there in each case. Now, from this, I'm involving using the same concept. It's still EM, but using electromagnets. I've got a pattern of 20 small electromagnets with the iron cores, so that we'll see this version compared to this version. And it's starting to build up a pattern of these field relationships to gravity. I feel it's very important, not only to anti-gravity work, but it's important to free energy too, because that's already been shown. So I guess that just about does it.
Tell us now about the bifilar coils as they run in several of these inventions. And if you like, you can face the camera.
It's now pretty well established that these bifilar windings, or they are actually non-inductive windings, have become a very significant component to free energy and anti-gravity, although they are particularly applicable to free energy because they've shown up. This is the third time, and Sweet's device is the third application of these non-inductive windings, and specifically over ferrite magnet coils. So it started out with Hans Kohler. He was the first one to show that, and then it went to the Swiss converter. They used that same type of component there, and then into Sweet's device. So there we have three applications of non-inductive coils over ferrite magnets. So they become a...
The magnetic component, and to leave the electric component only. Could it be that the electric component only gets in tune with the Earth's gravity field and starts siphoning off energy from the gravity field?
Yes, that's...
The magnetic component, if it is there and present, it does not allow that to happen.
That's quite a good observation, Vladimir, because, you know, there are all kinds of theories floating around about the mechanism that allows this to happen, but I think you put that as just about as succinctly as you can get. That is the key to it. Why? How else can you, explain? If you're canceling out the magnetic field, that you can say, well, that kind of opens the door to converting space energy. So it's a very significant component, and we need a lot more work to be done in that area. So I guess that about covers it, and it stopped raining, so...
I would... Let's put it here.
I would like to make a little remark here. When we speak about free energy, when we speak about space energy, if you would like to come closer to being the friend. Yeah. I mean, this is not perpetuum mobile, because energy is not created out of nothing, out of non-existence. I mean, only these of us that believe in a creator, they know that the major building blocks of the universe, energy, matter, and time, are created only by the guy who is on the topmost floor, who occupies the penthouse up there. For these of us...
That's a very colorful way
for these of us that believe in a creation, obviously, creation of matter and energy and time and everything in between, and all these zillions of permutations and combinations of them, are basically in the domain of creation itself, in the domain of the whole universe. So regardless of where we stand on the philosophical scale, obviously some of the things, some of the very important things, some of the fundamental building blocks of nature were left on purpose to be creatable only by the factors, the forces, the guys on the topmost floor, in order for us, otherwise we would be able to collapse the whole universe by basically pulling the foundation stone, the cornerstone, and then we can collapse the whole edifice. So definitely we are not talking about creation of energy out of nothing. We are not talking about perpetuum mobile. Heaven forbid perpetuum mobile. I mean, modern academics, the patent office gets a fit every time somebody submits a proposal for a perpetuum mobile. However, I have to point here that it's a very skillful propaganda and spin control and disinformation by the Illuminati and the bankers and everybody who owns shares in the energy business, in the energy industry, to create this hype against perpetuum mobile, basically very skillfully to create the monster of perpetuum mobile, to scare us, to make it absolutely unfashionable. I mean, the fastest way to lose one's job in academia is to start talking about perpetuum mobile, or maybe anti-gravity, or water skiing on the moon. Some of the topics that we've been discussing lately on in the media. The phone never stops ringing at home. So all these devices are converters, are transformers of one type of energy into another, of a type of energy that we know nothing about, we know very little about, into a type of energy that we know a little bit more about, useful, mechanical work, or electrical energy, basically these types of energy that we have discovered so far. Metaphysical sources like the Urantia book claim that in the universe there are 30 types of energies, 30 types of interactions, physical interactions. We have discovered 4, speculating about the 5th. There are 25 more to go. So, and even the energy architects of the mega universe, of the master universe, never cease to be amazed at the never-ending variety of ingenious inventions and creations that come to their knowledge from, to their attention from the lower levels of the universe, where countless numbers of inventors like John Kelly here try to solve the incredible puzzle of the universe. Anyway, we are living, we are swimming in torrents of energy. We are baited. We have to wade through torrents of energies. It's like sitting under the Niagara Falls and not pretending not to see the torrents of energy falling all around you, but listening to the hype of the Illuminati. Well, perpetuum mobile cannot exist, and everybody who talks about perpetuum mobile is a crackpot. So one of the most simple energy that we can utilize here is gravitational energy. Gravitational energy is not just the energy of falling bodies, which cannot be extracted because it falls once, but then you have to lift it up again, losing energy in the process, in order to let it fall and gain energy. So basically, very skillfully, we have been taught by the same textbooks, published by the same foundations and trusts owned by the same Illuminati and bankers behind them, that the gravitational energy is a potential energy, so that you cannot squeeze energy out of, let's say, falling weights, falling stones. However, nobody has taught us that the gravity circuitry of the universe is like the capillary system of the body. Energy comes from the heart, from the center, from the Isle of Paradise, according to the Urantia book, from the North Pole of Paradise, like the North Pole of the terrestrial field or magnetic field, or, I mean, basically, as above, so below. The fields, the fields around the elementary particles, around atoms, molecules, human chakras, the fields around planets, the electromagnetic-gravitic fields around the Earth, around stars, around the sun, around galaxies, and around the whole universe, are very similar in pattern. So basically this never-ending torrent of energy that comes from Paradise, from the North Pole of Paradise, according to the Urantia book, goes through the Lie lines, through the energy supplying circuits of the whole universe, to the smallest points, to the smallest corners of every planet. There are many works discussing the Lie lines of planet Earth. So in the universal gravitational circuitry, it is taken care of that every cell would be connected to a little capillary of energy, and this torrent of gravitational energy would never cease. Even if we take a classical approach to gravitational energy, basically every gravitational converter siphons off energy from the momentum of spinning of the Earth. Still, it would take millions or billions of years for the Earth to slow down perceptibly in its rotation around its axis by all these free energy gravity converters installed in cars and trains and in industry. So for all practical purposes, we can think of gravity energy as unlimited energy, at least a lot more unlimited than all the fossil fuel energies, basically of the type of the solar energy. So all of these converters that we talk about basically convert energy from the unlimited supplies of terrestrial gravitational energy, and basically Earth itself replenishes its gravitational energy through the gravity circuits of the universe. These are converters that, well, basically Tesla got kicked out of the Belgrade physics department for proposing the unthinkable. He proposed to build a perpetuum mobile, and rightfully enough, his professor kicked him out with indignation. So what was Tesla's crime? He proposed to put a turbine in the path of falling water to connect the generator to the turbine and to extract electrical energy out of the falling water. And his professor was enraged that this was blasphemy. This was perpetuum mobile. So we see now and again that academia always has interest of conflict of interest. Basically, things that come out of nowhere through people that have no formal education, and these of us that have been into metaphysical and UFO concept literature know that basically many of these designs are given on purpose to people without formal education, because if they were to have formal education, they would be fighting, they would be struggling with a new concept, and basically they would suffocate the whole idea.
Couldn't be done.
9 to 1, maybe 99 to 1, is the ratio of people without a formal education that come with these incredible devices. And probably this has been discovered by the Illuminati a long time ago, because their headhunter teams that were working in the Second World War, hunting down Nazi scientists and engineers from the numerous countless secret Nazi projects. These were teams that that did not cease to operate. Actually, the secret Illuminati reconnaissance and hit teams are their most important assurance that no matter what new design would appear, even in the home of a humble shepherd in Syria, as is the case of an anti-gravity inverted conical spinning water pump, basically a free energy water pump that spins under its own energy that it creates, and on top of that pumps water from a lower level to a higher level. Basically, that would allow a third world nation to freely irrigate its fields without any reliance on very expensive energy. This will be one of the many films that I have in mind to do in the near future. Actually, some of them have already been done and distributed, about free energy devices, about anomalies, physical anomalies around the field of free energy, the relationship of these anomalies to weight reduction, anomalous weight reduction, which is basically anti-gravity, and so on. John, would you like to show us the actual hardware that you use to demonstrate these devices? Let's turn off the camera right now. So here we would see the actual design of these devices. They're extremely simple. The total budget of these experiments would probably run not more than $50, maybe $100.
Well, these magnets, in that range, yeah, it's not far off.
It's not necessarily $3 billion to prove that some of the most essential laws of gravity do not hold, or that they have to be respectively modified for these new discoveries that have been made here.
Yeah, these neodymiums run at about $6 a piece. So, they're within the range of a relatively small budget. Now, this is an example of the bucking field. In other words, the magnetic plate with the magnets in the bucking mode. They're not horizontal; they're vertical. So the magnetic fields are essentially lateral, but also
north, where is south?
North, south. So this would be south, north.
North, south, north, south, north.
Right. Yeah.
These magnets are glued to a pressboard.
Yeah, that's correct. Yeah, the holding, it's just an L frame that's holding the magnets vertically. And
you will be dropping down?
Yes, it would be just falling like this. In other words, this plate, as compared to an inert plate, fell 31% slower, you see, and that's due to the magnetic flux.
Like you would put that metal part there?
Yes, I just used, in one case I used glass plates. It was cushioned. Anything that's inert, just the important thing was to get exactly the same weight and the same shape and the same surface texture. So that was important too. You can't have any variation in the surface, the texture of the material. But anyway, this is the essential construction. Now there are 5, 4, 20. There are 19 magnets. Originally I had 20, but in order to match the weight exactly, I had to take one of these magnets out so I would match the weight. So it's a little game to play with, getting to the precise same weight for each plate.
So can you give one more time the definition of the magnets? These are what kind of magnets?
Yeah, these are neodymiums. Now, the neodymium magnet, this specific magnet here costs $6 each, retail.
It's like about $120 for the magnet.
Yeah, that's right.
I see.
Yeah. So those are, of course, the most expensive item in the whole thing. The rest of it is just ordinary material. But you do see the difference in the having the magnets normal or horizontal as opposed to having them vertical and also bucking. So
What was the difference? How many times was
well, it's about double because the original test with the horizontal magnets was about 14%
magnets lying flat on their side?
on the face and horizontal to falling to earth, you see. But in this case, they're vertical, and the drop time was just about cut in half. In other words, we went from 14% to around
Why do you explain that?
31. Oh, because of the, see, in the original case, you just had a normal flux pattern, which was flat. But now when the flux patterns are bucking, you're increasing, you're actually squeezing the magnetic flux out into a wide loop, both top and bottom. So you've got more magnetic flux reacting against gravity. See, so it's almost self-explanatory that you would expect that because of a much increased flux pattern from each grouping.
I see.
See, so that's kind of a rough explanation of it, but
Now, how about the electromagnetic
okay.
side?
This would be the first electromagnetic plate. Now there again, you saw what I had in the photos there. There's your bifilar coils wound over barium ferrite magnets, which is which is essentially the same type of mechanism that Floyd Sweet had. And then here you see the characteristic of bifilar winding is that the ends come out, the two leads come out of the same end. That's all. You can always tell a bifilar wound coil that way when you see the leads coming out at the same end. So that's typical of this type of component.
And this one was a drop with power and without power?
A drop with power and without power, and it was quite significant. The differential drop percentage on this was 40%. Quite significant.
To drop this in an elevator shaft and manage to arrange it in a way so that it would keep its direction of dropping.
Well,
I think that would be a fascinating experience.
oh yeah, but you see there, unfortunately, I think there would be probably a tend for the plate to start canting. You know, the longer the drop, the more likelihood is that you're going to get a canting. So the 5-foot drop was sufficient for this to drop fairly horizontal.
Have you dropped any other configuration?
No. This, but of course, I will be getting into the later ones. I'll be getting into the second phase on the EM test, which will consist of the 20 small electromagnets, and then I'll be getting into the all-electric. So what I'm attempting to do here is to try and tabulate and eventually get into graphs of the field relationships, electromagnetic, electrical, and magnetic, you see, in relation to gravity, and hopefully get to a point where you can plot. In other words, as we get these test results, we can plot them into a graph, and you can see the interaction between, or comparison between, the electrical field and the magnetic field and the electromagnetic field. And I hope that's going, I believe that's going to tell us quite a significant picture of what, how these fields, the relationship to gravity. And I would very much like to get other researchers involved in this area, because I think it's going to be of great significance later on. We're going to learn more. It's a learning process, you see. This is
I think you're a danger to the scientific community, and the Committee for the Non-American Scientific Activity has to investigate. I think we have to start a new MacArthur committee here. Committee for what was it? You're a nut. You're a schizophrenic nut. I mean, that's what every academic would tell you. How can you trust, John, how can you trust your eyes and not believe the textbook? How can you trust your eyes? You should believe the party line.
I trust what I see and what I test.
You should believe the party line. You should believe the textbook.
No. This is what I believe. If I see, a mechanism like this doing something that is unexplained or is in an exploratory area, well, I think it's a learning process. We're starting to learn what the real world is all about and how the field forces interact. This is what it's all about. That's the world I'm trying to live in.
So for you, if the king wears no clothes, you would be shouting, "Get a full throat." You would not be reading the textbook and following the party line.
No. I've gotten away from that. I've been burned too many times with theory that, really doesn't get you anywhere. So when you get into the area of actual hardware, you're starting to learn something real.
John, tell us several words about Lloyd Jervis, the genius of bow dropping. You name it, Lloyd has dropped it. Every bow that exists on this planet, I think Lloyd has dropped it. And he discovered some incredible results, and probably one of the next steps would be about his inventions. But what do you know about him?
Very little. No, I'm sorry, I can't. I have been in touch with Lloyd, and I'm aware of some of his work, but I was not aware of him doing drop tests.
What other things has he done?
Boy, this is going back quite a few years now, so I don't recall exactly what they were. Oh yes, yes, he was working in free energy. Yes, I do recall that.
Something that I don't know.
Yeah.
I knew about the dropping of things.
Yeah.
But I knew nothing about the free energy thing.
Well, he didn't go into really specific detail on any hardware, but I knew he was involved in it. So I think some of it was kind of experimental, and I felt. I suppose he wanted to keep it proprietary, so he wasn't letting...
In a nutshell, Lloyd got a 2,000 feet precipice in a limestone mine, in a quarry. Anyway, vertical 2,000 feet precipice, 600 meters approximately, and he will drop balls from a platform on top and have some not very sophisticated, but I mean good enough measuring basically contacts and some time measuring circuitry. I mean the length, the height is so big that he would get a result way above any conceivable how should I say error in his measuring circuitry, and he would drop several balls at the same time with different diameter, different materials, same diameter. They were hollowed in the middle so as to have the same external diameter for the same aerodynamic resistance, the same weight, but made of different material: lead, iron, carbon, and so on. And he discovered with amazement that the fastest to fall were the carbon balls. The iron balls would fall with as much as 30% lag behind the time-wise, behind the iron balls. I think, but I would update this information before we do this tape, which is a fascinating experiment. I think that there is a lot that the two of you can discuss together. I mean, all these experiments with spinning and rotation and gyroscopic anti-gravity are such a taboo, and the newer the textbook is, the less it talks about spinning and rotation. The newer the textbook is, the more it is expurged of all these experiments in dropping, in dropping of weights, in measuring the time of drop, and so on. Because, I mean, what you just described here verbally is enough for at least one Nobel Prize. It proves the whole, technically speaking, because it is an experiment that changes one of the major foundations on which the whole physics, the whole edifice of physics is built. And that's why scientists are so reluctant to acknowledge such discoveries, because it means that they have to acknowledge tremendous amount of fame and money to someone, and we know that.
It's kind of interesting. I haven't received any response back from any...
Did you write to some university?
Yes, I did. Yeah, MIT. I'm in contact with MIT.
And what did they tell you?
Well, the first time they said that when I disclosed the first magnetic drop plate and the 14% differential. They said that was probably could be explained by the error within the instrumentation, which I thought was kind of that was hard to swallow, because 14% is kind of a sizable percentage to consider within an error. I would have thought maybe 4 or 5% in that range could be attributed to instrumentation measuring. But I let it go. There's not much you can do. This is a peer review process, so you can't challenge them because they hold all the cards, really. It's what you're talking about. Now, it's the same professor up there at MIT. He's no longer in the Magnus lab, but he's in the physics department. I sent up the latest one about the 31%, and I said, how are you going to explain 31% differential? I mean, you're going to say that's within the margin of error for instruments? I kind of, gave it to him a little bit because.
Did you get any?
No. That's the thing.
Let's hope with it. I think I'm going to call this same professor from MIT in a very serious business-like fashion, and I'll tell him that I'm calling from the American Academy of Sciences. Which academy? From the American Academy of Dissident Sciences, and we would inquire about his opinion. Thank you very much for your time and your attention. This was one more fascinating video interview here on location in Clearwater, close to Tampa, Florida, with the amazing Don Kelly, a person who has done alone with a budget of probably less than $200 what giant physics labs with budgets of hundreds of millions and billions of dollars have not been able to do.
I never thought of it that way. It's an interesting concept.
Thank you very much for your attention.
Okay, that's great.